Today we'll be doing the integral from 0 to 1 of the natural log of x divided by the square root of x times x minus 1 dx. And to start, we'll make a substitution. So we're going to let y equal the square root of x, but that means that y squared equals x, but that means that dx equals 2y dy. The bounds of integration will not change. So we have the integral from 0 to 1 of the natural log of y squared divided by y times y squared minus 1 times 2y dy. The y's cancel. We have twice the integral from 0 to 1 of the natural log of y squared divided by y squared minus 1 dy. We could rewrite this as 4 times the integral from 0 to 1 the natural log of y divided by y squared minus 1 dy. And from here I'll multiply the numerator and denominator by -1. So we have -4, the integral from 0 to 1, the natural log of y divided by 1 minus y squared dy. And from here, we'll make a trig substitution. So we're going to let y equal sine theta, but that means that theta equals arc sine y. That means that theta 1 is 0 and theta 2 is pi over 2. But that also means that 1 minus y squared is 1 minus sine squared, which is cosine squared. So we're going to have a -4, the integral from 0 to pi over 2, the natural log of sine theta divided by cosine squared theta. And dy is going to be cosine theta d theta. So cosine theta d theta. And we're going to leave the integrand like this because cosine theta divided by cosine squared theta, I can rewrite this as, if I multiply the numerator and denominator by sine theta, we're going to have a cotangent theta times sine theta over cosine squared theta. So now we replace this in the integrand. So we have -4, the integral from 0 to pi over 2, the natural log of the sine of theta times sine theta divided by cosine squared theta and times cotangent theta d theta. And I'll make a substitution. So we're going to let t equal the natural log of sine theta, but that means that dt equals cotangent theta d theta, but that means that e to the t is sine theta, and that means that e to the 2t is sine squared theta, but that means that 1 minus e to the 2t is 1 minus sine squared theta, which is cosine squared theta. So now we're going to use this. And the bounds of integration, so t1 will be the natural log of 0, which is approaching -infinity. t2 will be the natural log of 1, which is equal to 0. So now using this setup, we have -4, the integral from -infinity to 0, t times sine theta, but that's going to be e to the t equals sine theta. So we have e to the t divided by 1 minus e to the 2t, and cotangent theta d theta is dt. So we have a dt now. And then from here, we'll use the fact that 1 divided by 1 minus e to the 2t is the sum from 0 to infinity of e to the 2tk. So we have -4, the integral from -infinity to 0, t times e to the t, and then the sum from 0 to infinity, e to 2tk dt, and then swapping the sum and integral, we have -4, the sum from 0 to infinity of the integral from -infinity to 0 of t times e to the t times e to the 2tk dt, and e to the t times e to 2tk is the same thing as e to the t plus 2tk, which is e to the t times 2k plus 1. So we have -4, the sum from 0 to infinity, the integral from -infinity to 0 of t e to the t times 2k plus 1 dt. And then from here, we'll make a substitution. So we're going to let -z equal t times 2k plus 1. And solving for z, we have z equals negative t times 2k plus 1. And then the bounds of integration, z1 will be positive infinity and z2 will be 0. So now that also means that dz equals negative 2k plus 1 dt. And solving for dt, we have dt is dz divided by negative 2k plus 1. So now using this setup, we have, well, first of all, let's solve for t here. So we're going to have a negative z equals t times 2k plus 1. So this means that t equals negative z divided by 2k plus 1. So we have negative 4, the sum from 0 to infinity, and the integral from negative infinity to 0 of negative z divided by 2k plus 1. E to the negative z, dt is dz divided by negative 2k plus 1. And then from here we could, this will turn into a positive, and we'll use this extra negative to flip the bounds of integration. Well, actually, this will be a positive infinity. So we're going to have 4 times the sum from 0 to infinity, and then the integral from 0 to infinity of z over 2k plus 1 times e to the negative z divided by 2k plus 1 dz. So we now have this 4 times the sum from 0 to infinity, 1 divided by 2k plus 1 quantity squared, and we have the integral from 0 to infinity of z times e to the negative z dz. But this integral is just a gamma function at 2, which is just 1. So we're left with 4 times the sum from 0 to infinity, 1 divided by 2k plus 1 quantity squared. But the sum from 0 to infinity of 1 divided by 2k plus 1 quantity squared is equal to pi squared over 8. So we're going to have 4 times pi squared over 8 is the same thing as 4 times 2. And as you can see, the 4's cancel. So we're left with a pi squared over 2. So now we can say that, therefore, the integral from 0 to 1, the natural log of x divided by the square root of x times x minus 1 dx is equal to pi squared over 2. And so this is the final result.